So one of the interesting side findings that came up recently, reanalyzing what a Lewy body is actually composed of, was the finding that it does not necessarily involve too much aggregated amyloid α-synuclein, but aberrantly lipid-binding α-synuclein. So in my talk, I go a little bit more into detail in a model where we try to find a good cellular model organism to mimic this pathway and understand it a little bit better. Major findings are that if you get α-synuclein to bind more on the membrane, the TLDR would be that's bad. So you have to modulate the contact time of α-synuclein with lipids. If it's too long on lipids, it starts to aggregate, form these Lewy bodies, actually also causes vesicle trafficking deficits in the cell, which ultimately lead to its demise. If you never have it on the membrane, on the other hand, you run into a couple of other issues with its physiological role. So you have to kind of find the sweet spot, and the sweet spot can be modulated via lipid metabolizing enzymes. One part that we should focus more on α-synuclein and what lipids it likes to bind to, or like what makes a enduring lipid contact and what makes a transient lipid contact for α-synuclein, to study that role more. Just as a direct therapeutic potential target. There are already companies looking into that. So Yumanity, for example, in Boston has an SED inhibitor right now in Parkinson's disease patients, which is aiming exactly that, modulating the lipid membrane content, getting α-synuclein off the membrane, and hopefully that will improve patients' lives. And again, like if we have a good cellular model to understand that mechanism a little bit better.